Hi everyone. This week in Level F, we're going to be going over lessons 57 through 60. And you'll need your practice page number 3, worksheets 45 through 48, the activities for learning abacus, the Casio calculator, your 4-in-1 ruler, the math card games book, and then the basic number cards deck and the multiplication cards deck. In lesson 57, we'll be looking at square numbers and writing expressions algebraically. There is a correction if your book was printed before March 17th of 2019. I will leave a link to that correction page in the description, so please check that out to make sure that you have the correction before you start this lesson. The warm-up is the first box on practice page 3. And once that's done and checked, have your student work on problem 1 on the worksheet. Ask, what pattern do you see? Seeing patterns is so important. And if your child is having trouble with this, ask questions that allow discovery, such as, are the numbers you wrote even or odd? Are they in any particular order, or are they all mixed up? For section finding the next square, I'll demonstrate that activity for you.
Okay, so the instructions say to draw a 2 by 2 square and shade it. Go ahead and shade those. And ask your child, how would you represent these squares with exponents? So they would represent it by saying 2 squared. Okay. Next, you're supposed to add 2 more squares to the bottom of it. So how would you represent this as an expression? So they already have the 2 squared. What did you do to the 2 squared? You added 2 more squares, right? So the expression is 2 squared plus 2. Now I'm going to add 3 more squares on the right-hand side here. So what did I just do to this 2 squared plus 2? I added 3. So my expression is 2 squared plus 2 plus 3. And how much does that equal? Well, what kind of a square do we have now? We have 3 squared. So we could just write it as 3 squared.
Okay, so once you've demonstrated that, have your child do problem 2 independently and explain the answers. Notice the explanation on the far right in the right-hand column. If your child needs a more step-by-step approach to see the pattern, go ahead and use those steps to illustrate what's going on, because problem number 2 may actually jump a little bit too fast for your child. And if you're noticing that they're struggling with the problem, go ahead and stop and demonstrate how we got to those answers by doing the step-by-step approach. In the enrichment section, we're using the variable n. And the lesson book says, let n be any number. How do you write that number squared? So if you're getting a blank stare from your child, I would back up and say, if you pick a number, let's make it 4, how would you write that as 4 squared? So hopefully your child writes 4 with a little 2 as the exponent. If we don't know what that number is, we can use a letter such as n. So how would you write n squared? Now, that probably will solve the problem and they'll get it. Some kids get this concept right off the bat and others don't. So just stick with it by giving many examples. All right, so the next section is squaring a sum. So let's take a look at what that would look like.
So the directions say to draw a 5 by 1 rectangle. Okay, and we're going to shade the first 3 and ask your child, how could you write this as an expression using numbers? So hopefully they'll say 3 plus 2. If not, just go ahead and do it for them. All right, so now they want us to expand it so that this is 3 plus 2 squared. Okay. Go ahead and shade, just like you did the first one, up to the 3rd row. at the 4th and 5th row, shade the 2 over here so that it still looks like 3 plus 2. And you can ask your child, all right, so we just squared 3 plus 2. How would we write that? So they could write it like that. We need the parentheses so that the 3 and the 2 are both squared. Now we're going to look at how we came up with, or what components are put together to make 3 plus 2 squared. So we can say, what square do we have here? We have 3 squared. Plus, what square do we have here? We have 2 squared. Plus, what do we have here? That's 2 times 3. And what do we have here? 3 times 2, which is exactly the same thing, right? So we can say plus 2 times 3 times 2. Because we have 3 times 2 rectangles.
All right, so once you've demonstrated that, go ahead and have your child complete problem number 3 and make sure to check the answers and discuss any issues that happen to come up. The next enrichment should be easier to understand if you spent time explaining the first enrichment. In this one, though, your child will learn that the multiplication sign is not used in algebra. Instead, you just write the number and the letter next to each other or use parentheses. These 2 enrichments are really fun to learn, but it's not expected that your student will master these concepts. However, being introduced to them early on really does make algebra less intimidating. So ask the in conclusion questions and then play Crazy Squares, which is P23, and we do have a video demonstrating that game. For lesson 58, we'll be working with square roots. The warm-up questions are oral this time, and we'll remind your student what inverse means, because next they're going to learn that the inverse of squares is square roots. So let's take a look at the first exercise.
Okay, so the instructions say to have your child enter 49, 410, 9 on the abacus. So here's 49. And then to use the take and give method to make sure that we have the same number of beads on a row as we do rows. Okay, so in the beginning, your student might just have to do 1 at a time, which is fine. If not, they could go ahead and do 2 at a time. You just keep going, you can go back up to the top. And we see that, okay, we have 6 rows. Go ahead and start on the next row. We're getting close. I'm going to go ahead and move 2 beads. There we go. So we have 7 beads on 7 rows. This process is called finding the square root. Now, obviously, they're not going to have to use the abacus to find the square root every time, but using the abacus in the beginning to demonstrate how to find the square root makes finding the square root really concrete for them. So once they have found this, then they can be told that the way you write that is the square root of 49 equals 7, because we had 7 beads on 7 rows. Notice how I wrote the square root sign. This is not a division sign. Division signs usually have a curve or even just straight, but they don't have this little check mark. So this is the square root sign.
Okay, so you're going to go ahead and continue with the next example, which is what is the square root of 16? Make sure you ask the questions that follow that. Next, we'll look at non-perfect squares. Notice the procedure for estimating the square root of a non-perfect square. Before jumping into finding square roots on the calculator, it is good for your child to know how to get close. So definitely focus on the questions before moving on to the calculator part. All right. On the worksheet, questions 1 and 3 should be done without a calculator. I would also encourage your child to do number 4 without the calculator too, and then check the answers with the calculator. So then you can finish up with the in conclusion questions and play the variation of the game, which is explained in the right-hand column. That is square memory, which is P21. In lesson 59, we'll learn the term inscribed, and we'll work with inscribed squares and solve some more square root problems. The warm-up for this lesson is the second box of the practice sheet 3. After you have checked over the warm-up questions, ask your student the questions under the section Area Units. In the section Inscribed Squares, notice that you should wait to draw the third figure until after you've asked the few questions below the 3 squares. So don't go ahead and just draw all 3, just do the first 2. The dotted lines should help your child picture the triangles of the outer square folding in and covering the smaller square. Now, if you want, you could do this on a piece of paper and have them cut it out and put the triangles on top, or just cut out the square and fold the triangles in on top. After the second set of questions, have your child complete problems 1 and 2 on the worksheet and discuss the solutions. For problem 3, your student might jump to the conclusion that they simply have to double the length of the side. I would go ahead and let your child follow through with that thought and do the calculations, and then ask, what is the area of the smaller square? And what's the area of the larger square, the one that you just did? Is the larger area double or more than double than the smaller square area? So once the mistake is discovered, you can ask, what should the area of the larger square be based on the smaller one? And how can you find out how long the side should be? If they're still not sure, ask, in the smaller square, if you only knew the area, how could you find the side length? We know that the side length is 5 centimeters and that the area is 25. So what's the relationship between 5 and 25, right? So 25, the square root of 25 is 5. So if you know the area of the larger square, what is the square root of that? And that will give you your side. So this might seem like a lot of work. Once your child discovers the relationship, the solution will be obvious and not easily forgotten. It would be easier for us to just simply say, hey, find the square root of 50 centimeters squared. But then we'll end up having to tell them that over and over and over again. So take the time now so that they'll remember how to solve the problem. So then you can move on to problem number 4 and encourage your child to draw sketches of what is known. Really, this is some kids resist drawing sketches, but it is so much easier to see what's going on when you've drawn the sketch. And give your child time to really think this problem through and then explain the solution to you. If the answer is incorrect, make sure to ask questions that lead your student to discover the correct answer, just like you did in problem number 3. All right, follow up with the in conclusion questions and play square memory again if you have time. This lesson may have been pretty long and tiring for your student, so you could skip the game today, or simply do a different subject and come back to the game later in the day so that it's not too exhausting. For lesson 60, we'll be working on the Pythagorean Theorem and finding squares and square roots. This happens to be one of my favorite lessons because just like you, I memorized a squared plus b squared equals c squared, and it worked and I could plug in the numbers. But I really had no idea why it was working and what was going on. This lesson teaches your students the why and how of the Pythagorean Theorem. So after the quick oral warm-up, have your child complete problem number 1 on the worksheet. By doing this work, your student will discover the Pythagorean Theorem. Please, please, please do not tell them the algorithm for now. Later on, they'll know what the algorithm is. But understanding the why and the how, that's what's important right now. So continue the lesson doing the section, applying the Pythagorean Theorem. Then your child can complete problem number 2 on the worksheet. Follow up with the in conclusion questions and play square memory again. And that's it for this week. See you next time. Bye-bye.